All right, 3.1, quadratic functions and models. So the first problem say to, is this to, wait, am I on the right? Yeah. To match the equation in column 1 with the description of the parabola that is its graph in column 2. So basically we're just gonna say what it is and I'll tell you what letter it goes with because we don't need to do it exactly as they have it. So y equals x plus 2 squared plus 4. So the generic form of, or like vertex form, is y equals x minus h squared plus k, and the vertex would be at hk. So that means that whatever sign h is, or is on h, we put the opposite for the x value of its vertex, and then k is the same sign of whatever it is. So that means that the vertex for this one would be at opposite sign in here, so -2, and then same sign here, so that would be at +4. And if there's a negative sign out front, it opens down. If it's positive, so like this one, this is positive, it opens up. And that's what they're looking for with these questions. That option would be option A if you were to go back and check, since it's a matching section. Then 10, we've got y equals negative, and then in parentheses, x plus 2 squared plus 4. So what would my vertex be of this one? -2, 4 as well. And which way does this one open?
Down.
And this one opens down, so that's the difference. And that is option B. If you go back to check.
What page is this on?
Huh?
What page is this on?
Oh, 312. And we're not doing like everything in all of these sections. I'm kind of picking out like the highlights because, as y'all well know, these sections have like 100 problems in them typically, and we just don't need to do all of that. So all right, graph each quadratic function. Okay, so we're basically gonna be graphing the parabola. Give the vertex, axis, which is axis of symmetry, so that's the line that it rotates around, the domain, and the range. And then determine, oh, we're not doing that part. We're just doing parts A through D for these problems. So 23 through 36, only parts A through D whenever you're doing these problems. All right, so 26, we've got f of x is equal to x minus 5 squared minus 4. So I'm going to list off all the things at once, and then we'll graph it once we have all the information we need. So A is the vertex, B is the, I say AOS, it's the axis of symmetry. You can just write axis, whatever you want. C is domain, and D is range. So, not something that's asked, but which way does this open? Okay, this one's going to open up. So I like to point that out at the beginning just so that when I go to do my graph, I can make sure I'm doing it correctly. I know what it's supposed to look like. Where would my vertex be for this one?
5, -4.
Yep, 5, -4. So opposite sign in here, same sign out here. Now, the axis of symmetry is always going to occur at the x value of your vertex. It's a line, so we write it as x equals 5. So my x coordinate was 5, and so the axis of symmetry is at x equals 5. If you don't have the x equals, it is not right, okay, because just 5 is not a line. Now, I would save domain and range for after you have graphed it, because that's going to be easier to see once you've graphed it. So I'm going to set up So first and foremost, I'm going to draw on my axis of symmetry as a dotted line. So at x equals 5, I'm going to have a dotted line that symbolizes my axis of symmetry. Then I'm going to plot my vertex point. So that's the vertex point is always going to be on your axis of symmetry. If for some reason it's not, you've done something wrong. Okay, so at 5, -4, that's my vertex right there. Now, to be able to graph another point, I need to pick another x value on either side of the axis of symmetry, and then however far away it is on one side, then we also have a point on the same distance away on the other side. That's what the axis of symmetry is for. So I would pick, if I can pick 0, I like to pick 0 because it's an easy one. But if I put in 0, that's going to end up giving me 5 squared is 25. So that's going to be like crazy. So I'm not going to pick that. I would pick something that's like 1 away from your axis of symmetry. So I would either pick 4 or 6. It doesn't really matter. If we picked 4, then I would have 4 minus 5 squared minus 4. So 4 minus 5 would be -1 squared, which is 1 minus 4. So that's going to be at -3. So I have another point at 4, -3. So 1, 2, 3, 4, -3. Then all I have to do for the other side, I don't need to do any more math. I just need to know this was 1 away on this side. So I just need to go 1 away on this side and I have a point. And then I can draw my parabola. Nice and easy.
Is it going to be curved?
Yeah. So this is a curve. If you do it as like a V, that would symbolize an absolute value instead. So make sure it's curved. And obviously some of the graphs, just because of how it's going to be, it's going to look more pointed, but just try to round it out as best you can. So now I'm looking at the domain and range. That's the questions I haven't answered yet. So the domain is every x value that this takes on. Okay, so what would the domain be for a parabola? It's the same as what it was for the basic function.
5.
All real numbers, so you can either write it as the fancy R or you can write it as -infinity to infinity. Okay, because the farther out you go, the wider the parabola is going to get, and it just keeps going on and on forever. Okay, now the range values, I think what you were about to tell me was the range values. That's the y values that it takes on.
Yeah.
So the y values that it takes on is always going to be whatever your vertex is always going to be included. Okay, if it opens up, it's going to positive infinity. If it opens down, it's going to negative infinity. So in this case, it's going to be from, well, you said 5. It's actually -4. But I knew where you were trying to go with it. -4, including, so it's a bracket, to infinity because it opens up.
So 5 is in there technically.
5 is included, yes. I I knew what you were trying to say. You just didn't give me the y value. You gave me the x value instead.
Technically, I'm right because it's infinity, so 5 is in there. I was gonna count.
5 is in there.
I was gonna count.
So yeah, so remember domain is x values for every parabola. For every parabola, domain is going to be negative infinity to infinity. Okay, so if you can remember that, all you really have to change is the range when you're doing your problem. Let's look at another one. 28. F of x is equal to negative 3 times x minus 2 squared plus 1. So which way does this one open?
Down.
Okay, this one opens down because it's negative. Now, the only thing that this 3 out front tells me is that it's not going to affect any of our other information. The only thing it's going to change is those points when we're finding the points from the axis, like the distance from the axis of symmetry points. That's the only thing that 3 is going to change. So, let's set up what we need to find. All right, so vertex would be where?
3, negative 2.
Nope.
2, 1, 2, 1.
Yep,
Oh, I was
2,
reading
1.
the wrong thing.
Yeah. You can kind of just cover up the stuff that's in front because all we need is what's in the parentheses and then the number after. So where's my axis of symmetry?
2.
And how do we write it?
X is equal to 2.
X is equal to 2. So now I can set up my graph. So I've got axis of symmetry at x equals 2, so I've got a dotted line going there. I've got a vertex at 2, 1. Now, I know it's going to open down, so I just need to make sure that I stay aware of that. I would pick, again, something that's only 1 away because when you subtract that 2 off in this case, then it'll give you something that's easier to work with. So I would say use 1. So I plug in 1. I have negative 3 times 1 minus 2 squared plus 1. So that's negative 3 times, let's see, that's negative 1 squared, which is just 1, plus 1. So negative 3 plus 1 is negative 2. So I have a point at 1, negative 2. So 1, negative 2, I've got a point here. 1 away on the other side, I've got a point. And then connect the dots. So what's my domain for the parabola?
1,
Domain. X values.
2 to infinity.
Domain.
All
All real numbers.
That was range, wasn't it?
Alright, now try range.
2 to infinity?
Y values.
1 to infinity. Oh my goodness.
Negative infinity to 1.
Negative infinity to 1. Including 1. Okay, if you go back and you plug a y value in and it's not in your range, something like that should be, you did something wrong. Or vice versa.
Can we just find the domain range with the vertex and which way it opens?
Yeah, you can. I'm just a visual person, so I like to see the graph. But yes, you can. The volleyball.
I couldn't read that. I was trying to figure out what the volleyball meant, and then I realized it was
He's like, the volleyball.
the volleyball. Yeah. That makes sense now. Every 10 minutes, I'm staring at that.
F of x equals 2x squared minus 4x plus 5. So this one is going to require us to do something a little different. This one is not in vertex form. So we're going to get to use a different method of finding it. To find h if we are not given it in vertex form. So h is going to be the x value, k is going to be the y value. We're going to do minus b over 2a, and that's going to give us h. So a, b, and c are the letters. Okay, so just like when we have, a normal function, or not a function, when we have, well, it is a function, but anyways, when we have like the two parentheses or whatever that we multiply and we FOIL, what it gives us, basically how we do that, or what those letters are, and that's what those are. And then k is at f of h. So whenever we get h, then we just plug it into the function and we get k, and that will be our other value. So I'm still going to be finding vertex, axis of symmetry, domain, and range. So minus b over 2a, so that's going to be negative, but b is also negative, so negative 4. So that's going to become positive over 2 times a is 2. So that's going to give me positive 4 over 4. So 4 over 4, which is 1. So that right there, once I find that, that tells me the x-coordinate of my vertex. It also tells me my axis of symmetry is at x equals 1. Now I take that value and I plug it in up here to this equation, and I can find k. So f of 1 is 2 times 1 squared minus 4 times 1 plus 5. So that's 2 minus 4, so negative 2 plus 5 is 3. So my vertex is at 1, 3. Axis of symmetry is at x equals 1, so now I can set it up. You can find the domain and range if you are so inclined beforehand, or you can graph it first. Alright, so axis of symmetry is at x equals 1. So I'm going to put my dotted line. Now, I didn't point out with this one, but I can still look at the very first term and decide if it's going to open up or down based on if it's positive or negative. So which way is this one opening? Up. Opens up. Okay, because it's positive. So I've got a vertex at 1, 3. So then in this case, these type of problems, when they're like this, I do like to pick 0 because it makes everything but this c value cancel. So if I plug in 0, I get that 0, so I'm left with 5. So at 0, 5, I have a point, which also means 1 away on the other side. So at 2, 5, I also have a point. And I have another parabola. So what's my domain? X values.
Okay. 1. No.
Domain.
No.
The domain's going to be the same for every
all
problem.
all real numbers.
All real numbers.
Yes.
Okay, negative infinity to infinity. All real numbers. What's my range?
Negative infinity to 3.
Does it open down?
Oh, 3 to negative. 3 to infinity.
3 to infinity. Okay, goes the direction that it opens, including 3 to infinity. All right, let's look at one more. 34 f of x is equal to negative 3x squared plus 24x minus 46. This one could be brutal. Might not be picking 0 for this one. I don't really want to go all the way down to negative 46. But we'll see. I don't know what happens. All right, so I'm going to be finding same stuff. All right, so minus b over 2a. That's going to give us the x coordinate. Yep, so 2 times negative 3, which is negative 6. So that's going to be positive 4. So that's my x coordinate. It's also my axis of symmetry. Now we're going to plug 4 in.
Yeah, that's a lot of numbers.
We're going to hope it's not awful. So f of 4, we've got negative 3 times 4 squared plus 24 times 4 minus 46. So let's see. This is 16 times negative 3 would be negative 48. Right? Plus 96 minus 46.
Wait, wouldn't it be negative 12 squared? So that'd be 144, right? 12
No, you got to square the 4 first.
Oh, okay.
Then
okay.
multiply by the negative 3. Okay, this might not be as bad as it looked. So 96 minus 46 would be 50, and then 50 minus 48 would be 2. So that's not awful. Looked like it could be really nasty, but it worked out. All right, which way is this one going to open? I may have already said it. Opens down. Bless you. All right, so axis of symmetry is at x equals 4. Vertex at 4, 2. Now, I usually say I like to pick 0 in these type of problems because it makes everything cancel except for this, but I really don't want to go down to negative 46, so I'm going to pick something a little more reasonable. So I'm going to pick probably 3 just because 1 away shouldn't be too crazy. So I'll have to actually do some math over here again. So negative 3 times 3 squared plus 24 times 3 minus 46. So 3 squared is 9 times 3 is 27. That's negative. So negative 27 plus 72 minus 46. And then
That'd be negative 1.
is it? Probably. Yeah. I think so. Negative 1. I'm really bad at quick math. I used to be so good at it. Not anymore. So that means I have a point at 3, negative 1. I've got a point there. Then I've got to point 1 away on the other side as well. And connect. So what's my domain?
All real numbers.
All real numbers. There we go. Domain is always the same for these problems.
Okay.
Range. Think about which way it opens.
2 to infinity? No. Negative infinity to 2.
Yes, negative infinity to 2. I knew you'd get it eventually. And we include. Okay. So whatever your vertex y value is, we always include that in our range, and then it's either negative infinity or positive infinity based on which way it opens. All right, so your problems are 7, 9, 25, 27, 29, and 31. And just something to point out really fast, you don't have one like this, but problem 23 had f of x is equal to x minus 2 squared, and that was it. Okay, so the vertex for this one, just so you've seen this, would be at opposite sign, so 2. There's nothing out here, so it would just be 0. So the vertex would be at 2, 0 for that one. So just wanted you to be aware in case there's nothing written there. That's why, or that's what it looks like.